there are two methods to evaluate a definite integral using U substitution. Another name for U substitution is called integration by substitution. Let's do two integrals. I want to do this one first. We have 10 times x to the 9 power divided by 1 plus x to the 10, and then x goes from 0 to 1, and then after that I want to do one for trigonometric function. So for this integral, what is u going to be? So you are going to let u equals to the denominator. So in this situation, you have a numerator divided by a denominator. We usually let the u be the denominator. So we have u equals to 1 plus x to the 10, and then you take the derivative. So the derivative of 1 is 0, then this is 10 x to the 9 power dx, and then we isolate dx on one side. We have 1 divided by 10x to the 9 power du equals to dx, and then we will do a change of variable. So that is, we are going to replace that dx with this dx. So we are going to do this, and this is called change of variable. All right, so change of variable. And then what is the next step? The next step is, do you see that there is a integral x goes from 0 to 1? So in fact that I should put x equals to 0 and x equals to 1, but normally people don't write that. So as long as you see that this is a dx integral, you know that that is x equals to 0 and x equals to 1. So since we are going to do a change of variable from dx to a du, the 1 and a 0 should be for in terms of u. So how do we do that? Let's do that in red. So you have to find out what u equals to, what x equals to, what u equals to when x is equals to 1. So you plug it in to the u. So this is 1 plus 1 to the 10 power, that is equals to 2. And then u of 0, this is 1 plus 0 to the 10 power, that is equals to, what is that equal to? That is equals to 1. All right, so you have 1 and 2. And then how do we put this? So when you rewrite your integral, this should be u equals to 2 and u equals to 1. And then what else do we do? So this is an integral from u equals to 1 to u equals to 2. And then the top is 10x to the 9 power, the denominator. You already let that equals to u. And then what is the dx? The dx is in the yellow box. So that is multiply 1 divided by 10x to the 9 power, and then a du. All right, so do you see a cancellation in there? You get rid of the 10x to the 9 power and the 10x to the 9 power. So this cancels with that, and then you have to check your work. You are doing a du integral right now, so that means you cannot have x in the integrand anymore. So we only have 1 over u. All right, so that is good. Then what do we have here? So we have integral. We have integral u equals to 1 to 2, 1 over u du. So this is not a power rule. The integral of 1 over du is an absolute value, right? So this is ln absolute value u, and then such that u goes from 1 to 2. And then you apply the fundamental theorem of calculus. This is ln 2 minus ln 1. And then since ln 1 is equals to 0, the answer is ln 2. Is the absolute value optional? The answer is no, because ln of negative is undefined. You need to put the absolute value in there in case you will have to plug in a negative. So what if that is from negative 6 to a negative 2? Then the absolute value helps you to get rid of the negative. And then what is the other way to do this, to find this definite integral, to evaluate this definite integral using a u substitution? So for the other method, we still use the u substitution first. So for the u substitution, I am going to do this one more time. So we are going to let u equals to, so u is equals to 1 plus x to the 10 power, and then du equals to 10x times x to the 9. So 10x to the 9 power, did I say times 9? 10x to the 9 power dx, and then 1 divided by 10x to the 9 power du, that is equals to dx. And then you do the change of variable. You are going to replace this dx with that. So change of variable. And then we are not going to change the 1 and a 0. We will just leave the 1 and a 0 in there. And then what do we do next? We are going to do an integral. And then 10x to the 9 power divided by u. And then the dx is 1 divided by 10x to the 9 power. And then a dx, du. Now, you are going to ask me, hey, we are trying to evaluate a definite integral. Where are the 1 and the 0? So the answer is we are not going to write them right now because this is a du integral. So if you put a 0 and a 1 in there, that is not right, because for a du, that is supposed to be what equals to for the lower and upper limit. So it is incorrect to put a 1 and a 0 in there. So how do we get back to the definite integral? Well, we will just integrate this first. So for the integration, you get rid of the 10x to the 9 power, right? So this one you have integral 1 over u du, all right? And then that is ln absolute value of u, right? We are not going to do the plus c because we are trying to evaluate a definite integral. So you have an absolute value. Okay, then good, we have this is correct. Then if you don't want to do this step, then you will end up with a ln absolute value of u. This is fine because we let u equals to 1 plus x to the 10 power, right? And then here is a reason why I picked this problem. So you let u equals to 1 plus x to the 10, and then when you plug it in, you can actually change the absolute value to what? To a parenthesis. Do you know why? How come I didn't use the absolute value? If you use the absolute value, is this correct? I will say that is partially correct if you insist to use absolute value. So we don't use no absolute value. Why? Because since 1 plus x to the 10th power is surely greater than 0, you take a number, either positive or negative, you raise that to the 10th power. 10 is an even power, so the answer must be positive. Positive plus 1 must be positive. So since 1 plus x to the 10th power is always positive for any x, we do not need the absolute value. And then how do we evaluate this definite integral? So this is easy. You have ln parenthesis 1 plus x to the 10th power, and then now you do this such that x goes from 0 to 1. And then you use the fundamental theorem of calculus. You have ln 1 plus 1 to the 10th power, and then minus ln 1 plus 0 to the 10th power. And then that gives you what? That gives you ln 2 minus ln 1, right? And then ln 1 is equals to 0. So the answer is equals to ln 2. So you get the same answer. Now, at the end of the day, which method should I use? When I was learning calculus, the first time learning calculus, I learned both. But which one does the book use? The book used the one on the left. Okay, the book used the one on the left. So when you do your work, especially you are doing a written test, you have to show your work to your professor. I will just use the method on the left. All right, but it is good to know both. Right, you should know more. Okay, let's do one more. Let's do one that requires trigonometry. Let's pick a different color. How about we pick an orange? So let me give you another integral. I want to do integral from 0 to pi over 2. And then how about e to the negative sine of theta multiply cosine of theta and then d theta. Let's use two different ways to evaluate this using a u substitution. So since we have a sine inside the exponential function, I am going to let u equals to negative sine of theta, and then du is equals to negative cosine of theta, d theta, and then you have 1 divided by negative cosine of theta, du equals to d theta. So for the popular method, before we get into that, let's do the change of variable. We are going to replace this d theta over there. And then other than that, we have to change the 0 and pi over 2 to this. So we are going to do u of pi over 2. So that is equals to negative sine of pi over 2. So sine of pi over 2, that is a 90 degree. At that point, y is equals to 1. So you have negative 1. 1 negative times a 1, so that is a negative 1, and then u of 0, that is negative sine of 0. Sine of 0 is equals to 0, so this is equals to 0. And then that brings me to the next question. The next question is, let me just do it right here. So you have u equals to negative 1, and then u equals to 0. And then for the rest of the stuff, you have integral. And then this is a e to the u, right? E to the u, and then you have a cosine of theta, and then the theta, and then the d theta becomes 1 over negative cosine of theta du. All right, that part came from the change of variable. Now you are going to ask me a question. Hey, look at the upper and lower limit. Hey, usually the upper limit is greater than the lower limit, right? So let's say from 1 to 2, from 1 to 10, from negative 2 to 5, the upper limit is greater than the lower limit. Now in this case, the upper limit is less than the lower limit. Is this going to be a problem from 0 to negative 1? Should I swap them? The answer is no. Do not swap them. So once again, you got the u equals to 0 and negative 1 from this step. Do not swap them. In u substitution or integration by substitution, it is okay. Once again, it is okay to have an upper limit greater than the lower limit after you perform this step, assuming your math is right. So this is absolutely okay. So do not swap anything. All right. So we get rid of the cosine, and then we have, let's get, we are in orange. So that is equals to from 0 to negative 1. So we have a negative, right, e to the u du. Look how easy it is. So that is negative e to the u. U goes from 0 to negative 1, and then you just plug in. So negative e to the negative 1 minus negative e to the 0 power. So this is negative 1 over e, right? And then minus is a plus. U to the 0 power, please don't tell me that is equals to 0. U to the 0 power is equals to 1. So the answer is negative 1 divided by e plus 1. This is the final answer. And then how about the other method? The other method is here. So you have 0 to pi over 2 e to the negative sine of theta, and then cosine of theta d theta. So the other method, you have to go through the u equals to negative sine, derivative equals to negative cosine, and then d theta, and then 1 over negative cosine of theta du equals to d theta, and then you do the change of variable. You replace this over there, change of variable. And then you have your integral, and then you do not write the 0 and the pi over 2. Just leave it empty, e to the negative u, or e to the u, and then you have a cosine of theta, 1 times negative cosine of theta d theta. You cannot mention 0 and pi over 2 without showing this step, because this, du, because this is a du. This is supposed to be what u equals to, not what theta equals to. All right, so you cannot mention anything without showing this step. So we will just do an indefinite integral right here. So we have an indefinite integral, negative e to the u, and then du, then this is equals to e to the negative e to the u. What is u? E to the u, right? And then what is u? U is negative sine, so you have negative e to the negative sine of theta. So this is the result of the indefinite integral. Now we are trying to use fundamental theorem of calculus. So we have a negative e to the negative sine of theta, such that theta goes from 0 to pi over 2. And then you plug it in, so negative e to the negative sine of pi over 2 minus negative e to the sine of 0. So what do you have? You have negative e to the negative 1, and then plus minus, right? Sine of 0 is equals to 1, and then e to the 0, sine of 0 is equals to 0, and then e to the 0 power is equals to 1. So at the end of the day, you get the same answer. Now, one more time, which method should I use? Every single textbook use this. I will just use that on the test because I don't want to surprise the grader. But it is good to know both methods. Okay, so that is the end of this video. If you like the way I teach integration, U substitution, give me a thumbs up, give me a subscribe if you are new to the channel. I won't say goodbye because I will see you all in the next video. Signing out.